Okay, in this lesson we're going to talk about linear equations. So first of all, what is a linear equation? Well, a linear equation is an equation of one or more variables of just the first power. So for example, 2x plus 3y equals 6 is a linear equation. 5x minus 7y plus 8z equals 11 is a linear equation. Notice that in the first equation, the x and the y are simply to the first power. And notice in the second equation, the x, y, and z are also to the first power. And so these are examples of linear equations. Now, linear equations can have many, many variables, even up to thousands of variables, hundreds of thousands of variables. And we only have so much of an alphabet to borrow from. So what do we do in those cases? Well, in those cases, we start using subscripts. And so 5 times x subscript 1 minus 3x subscript 2. So I'll just call that x sub 2 plus 7x sub 3 minus 5x sub 4 equals some constant, which I'll just say is 10. And so this linear equation has 4 variables, x1, x2, x3, x4, and they're all to the first power. So what does a solution to a linear equation look like? So let's say I have a constant a sub 1, x1, plus a sub 2, x2 equals some constant that I'll just call b. Now in this case, a sub 1 and a sub 2 are not variables, they're constants, which means a sub 1, a sub 2, and b are just constants that belong to the real number system. Now x1 and x2 also belong to the real numbers, but a linear equation doesn't have to only be in the real numbers, just as a side comment. But in this case, we're going to treat x1 and x2 as real numbers, but we don't know what they are. So what these are called unknown values. Unknown values. Okay? All right, so what would be an example of a solution? Well, a solution would be something like S1, comma, S2. It would be an ordered pair. S1, S2, where S1 is substituted in and S2 is substituted in. So A1 times S1 plus A2 times S2 equals B. So okay, let's give an illustration of that. So let's say I have 2x1 minus 5x2. And let's see here. Let's go ahead and say that this is equal to negative 13. Now, what if I allow x1 to be the value of 1 and x2 to be the value of 3? So now the question is the ordered pair 1, 3 a solution? Would this be my S1 and would this be my S2? So the way that we figure that out is we substitute. So we have 2 times the number 1 minus 5 times the number 3 equals negative 13, and we're going to put a question mark above it. So 2 times 1 is 2. 5 times 3 is 15, so that's negative 15. I could write that a little bit better. There we go. And so 2 minus 15 is negative 13, and so I get an identity. So the answer is yes, 1, 3 is indeed a solution to this system. So let's go ahead and mark that. This is indeed a solution to the system. Well, are there any other solutions to the system? Well, yeah, there's actually infinitely many in this case. What we could do is this. We could take our equation and solve for x2. That means to isolate. So if I take 2x1 minus 5x2 equals negative 13, first thing I'll do is I will subtract 2x1 from both sides. So negative 5x2 equals negative 2x1 minus 13. And now I'll divide everything by -5. And what I've just done here is I have solved for the variable x2. So now, if I choose any real number I want, so for example, let me go ahead and choose the number 2 for x1. And all I have to do is substitute 2 into here now. And so this becomes 2/5 times the number 2 plus 13/5. 2/5 times 2 is 4/5, and 4/5 plus 13/5 is 17/5. And what that means is that the ordered pair 2, 17/5 is also a solution to the system. Now, that's pretty basic. You'll find that in any Algebra 1 class. Now, one way to find a solution to a system of equations is to parameterize. So let me say, for example, I have 5x1 minus 8x2 equals, let's just use 15 for now. All right, so what do? Well, in this case, what I'm going to do is I'm going to let x1 be represented. Its solution is some number called t. So t is the solution. And so now if I substitute this, I get 5t minus 8x2 equals 15. T is a parameter, and it belongs to the real numbers. Now let's solve for x2. So we subtract 5t from both sides. Negative x sub 2 equals negative 5t plus 15. Divide everything by -8, and so that's 5/8 t minus 15/8. And now we have the solutions in an ordered pair in terms of a parameter t. So t is the first solution to x1, and the second solution to x2 is 5/8 t minus 15/8. Now take any real value t and plug it into that ordered pair, and you've got a solution to this system. How do you parameterize something that has more than 2 variables, more than 2 unknowns? So let's say I have 2x1 minus 3x2 plus 4x3 equals, let's say, 24. So how do we solve something like that? So one thing we can do is we can let x1 be parameterized by t, and we can let x2 be parameterized by another parameter called s. And then we solve for the unknown x3. And so 2t minus 3s plus 4x3 equals 24. And so now we subtract 2t and add 3s to the other side. So 4x3 equals negative 2t plus 3s plus 24. And now we divide by 4. So x3 is negative 1/2 t plus 3/4 s, and then plus 6. And so now the solutions to this system are t, comma s. The first two are independent parameters. And the last one is a dependent parameter depending upon t and s, plus 6. And so this ordered triple represents the solutions to a system. All right, well, what would be an example of something that's not a linear equation? x1 plus x2 squared equals 5. That's not a linear equation. x1 minus 3 sine of x2 equals 7. Can't have power, and you can't take a trig function. You can't take any operator, really, other than a constant times a variable. x1 times x2 plus x3 equals 1. That's not a linear equation because you can't have the product of two variables. The square root of x1 minus x2 equals the square root of 2. This is not a linear equation because you can't take the square root or the cubed root or any root of a variable. There are a few equations that are linear but might look like they're not. So for example, the square root of 2x1 minus e squared x2 equals 3. That might not look like a linear equation because you've got the square root of 2 here. But the square root of 2 is just a constant. You're not taking the square root of the variable itself. And e squared is just a constant. You're not squaring the x2 variable. So the powers of x1 and x2 are still 1. And so yes, this is still a linear equation. So okay, hopefully in this lesson I've given you some idea of what a linear equation is. I've hopefully helped you to understand how to parameterize a linear equation to find its solutions, whether it's an ordered pair or an ordered triple or even more than that. And also hopefully in this lesson I've given you some idea of examples that are not linear equations. So that's it for this particular lesson. God bless you wherever you are today.